Good day, ladies and gents. We're going to be continuing our Unit 11 EOC review. We're doing Unit 4 today, which is on triangles. So make sure you guys have out your hot topics. And we have this big old list of things, including classifying triangles, stuff like that. So we're going to keep this out. So what we're going to work on today, so which worksheets? Okay, we're definitely doing 8, 11, and 12. And if we have time, we'll give these a try. 9 and 10. So we'll see what we can do. All right, so we're going straight to page 8. Going to page 8, flipping to that page right there. All right, let's get this going. All right, so, okay, so for page 8, if we look at our hot topics, making sure you're looking at your hot topics about the triangle inequalities. So for that, we have this right here. So basically, we're going to have these triangles. And what makes a triangle? So if you have two lengths, the third side is those two sides subtracted or those two sides added together. So if you stretch this out, right before it makes a straight line, it can still be a triangle. But as soon as you stretch it out all the way, then it's not a triangle anymore. That third side would be part of a line. So if I zoom out a little bit and we focus on this, so this is a triangle, so still a triangle, still a triangle, still a triangle, and now it's not a triangle, it's a straight line. So I just have to be a little less than that, and now it makes a triangle. And the same thing if you subtract those. So still a triangle, still a triangle, still, so I can still make a triangle, 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 boom, not a triangle anymore. Now it's just a straight line. So I have to be just a little more than the two numbers subtracted, but just a little less than the two numbers added together. Okay, so stuff like that. All right, so if we have these two sides, okay, so take the two lengths. So the lengths of two sides are 7 and 11. Which inequality are all the possible numbers? So all I have to do is take those two numbers. So it would be 7 minus 11. The absolute value of that has to be less than x, which is less than the two numbers added together, 7 plus 11. And let me focus on that just a little better. All right, so if you subtract those two numbers, so 7 minus 11, we would get negative 4. But we always wanted the positive version of that, so it's just 4. And so it's anywhere between 4 and 18. You cannot touch 4, you cannot touch 18. So it's between these two right here, but you see how there's a line underneath? We don't want that. That means we can actually touch 4. So we want this one. So D is the better answer. And where did we get that from? From this right here on our hot topics. All right, so number 2. Okay, Sarah's building a triangle pen for her pet rabbit. If two sides measure 8 by 15, all right, so a triangular pen, right? What is the measure of the third side? So it's just triangular. It's not right triangle or anything like that. So it has to be somewhere between 8 and 15. So we're going to take the two numbers. So 8 minus 15, absolute value is less than x, which is less than the two numbers added together. All right, so 8 minus 15, we get a negative 7, but we always want the positive version of that. So it would be somewhere between 7 and 23. But we cannot touch 7, so that's bad, and we cannot touch 23. So as long as if it's somewhere between 7 and 23, we're good to go. So the answer would be A. All right, number 3. All right, so number 3, the plot of land illustrated in the accompanying diagram has a perimeter of 34. All right, so basically perimeter. So perimeter, what that means is you add all the sides together. Add all sides, and it will equal 34. So if you add all the sides together, it will equal 34. That's what perimeter means. Find the length in yards for each of the sides. Okay, so we know that all these sides are going to add up to 34. So let's do that. So x plus 3 and 3x minus 1 and 4x. So those three sides are going to add up to 34. All right, so we have x, that's 1x. So let's put that 1 in front of it, and that helps us out. So 1, 3, and 4, put those all together, and we get 8x. And then we have a positive 3, a negative 1. So that would be a plus 2 is equal to 34. All right, so then we're going to subtract 2 from both sides. So we're just solving. So ax equals 32. And then we're going to take that ax. We're going to divide by 8 on both sides. I'm just showing more work than I need so you can see what my steps are. So 32 divided by 8, and we get x is equal to 4. All right, so now, did we answer the question yet? Did they ask us for x? No, they said find the length of each of the sides. So we have to plug this back in. So plug this back in. So I'm gonna be putting 4 plus 3, and I'm doing 3 times 4 minus 1, and I'm doing 4 times 4. So basically everywhere there I saw x, I'm plugging in 4. So what does that turn into? That turns into 7. That turns into 11. And that changes into 16. Okay, so these are the sides that we got. Now, could these measures actually represent the sides of a triangle? So let's double check. So we have 7, 11, and 16. So if I take these two first sides, and if I subtract those two numbers, 7 minus 11, absolute value, is less than x, which is less than 7 plus 11. Now the question is, does 16 work in here? So 7 minus 11, I would get 4, because you always make it a positive, is less than x, which is less than, add the two numbers, we get 18. The question is, does 16 make this happy? Is 16 somewhere between 4 and 18? Yes, it is. So yes, it is a triangle. So yes, x equals 4, and 7, 11, and 16 satisfies the a minus b absolute value is less than x, which is less than a plus b. Or instead of x, we could just put c here for the third side, whatever works. Awesome. All right, so make sure you guys have that copied down. All right, number 4. Okay, so in the diagram, we have these. So D is a point on here. So D is on a point between A and B. So D is right about here, right? We don't know if it's smack dab in the middle. We just know it's on here. So middle, not sure, right? We have no proof of that. Now we know that A to C is 7. We know that A to D, where's A to D? A to D is 6, and B to C is 18. So, and this is not drawn to scale, so we have no proof of anything other than these numbers. The length of D to B. So here's D to B. What could the length possibly be? All right, so if I just focus on this for a second, like do the things that you are used to. We know that, so a couple things. We know that we have 7, we have 18, and we have this missing side. So let's just call this like x right here, right? So, and so this other side right here would have to be x plus 6. Now, if you're not comfortable with that, I'll show you a different way how to do this. But let's just put x plus 6 just for the heck of it for right now. So we're going to take these two first numbers. So 7 minus 18 absolute value is less than our third side, right? X plus 6, which is less than 7 plus 18, right? Okay, so if we subtract those two numbers, we would get 11, we always make it a positive, is less than x plus 6, which is less than, add the two numbers, we get 25. Now, this is a three-sided teeter-totter, so what we're going to do is we're going to subtract 6 from all three sides. And when we do that, we would get 5 is less than x, which is less than 19. So x has to be somewhere between those. We cannot touch 5, we cannot touch 19. So it can't be this one, it can't be 25, and it can't be 19, so 12 was the only one that worked. So what was another way how to do this? Well, what we could do is 7 minus 18 is less than our third side, right? Is less than 7 plus 18. So the other way to do this was 11 is less than C, which is less than 25, right? So this number had to be somewhere between 11 and 25. So you would just plug in these random numbers to make sure it satisfies this. So if we plug in 5, 11 doesn't work. If we plug in 12, so I'll just 7 plus 5 equals 11. Does 11 satisfy this? No, it did not. If I plug in 6 plus 12, that would have been 18. Does that satisfy this list? Yes, it does. If I do 6 plus my 19, that would be 25. Does that satisfy this list? No, it does not. And then 6 plus 25, that makes 31. Does that satisfy this list? No. So those were two different ways how to do this one. All right, cool. And then number 5. All right, so number 5, use the figure above, which it's not above, it's right here. Complete each statement of less than or greater than, right? Okay, so let's see. BAD. So BAD. So where the angle is at A, so BAD. Now you see this angle? What did it project? So it projected the number 5. So that's what's opposite of it, right? 5. It projected 5. So I'm going to write down what it projected. It projected 5. So I'm focusing on this triangle. And then ABD. ABD. So it's at B. What did it project? It projected 6. So on the same triangle, so I'm focused on this triangle right here. When on the same triangle, it projected 5 and 6. So you eat the bigger number. So we eat the bigger number and we point and left the smaller number. So that would be this. And then you would just rinse and repeat for the other one. So I'll leave that up to you guys. So like what did it project? So I'm looking at B here. So CBD. So in this case, I'm focused on this triangle, the blue one. CBD, what did it project? And then what about C? So if I go BCD, what did that project? So write down those numbers and you would eat the bigger number, right? And we do the same thing on the other one. So I'll leave that one up to you guys. All right, and number 6. Number 6, is it possible for a triangle to make these sides? So what you're going to do is you're going to do what we've done before, subtract the 2 numbers, add the 2 numbers, and see if the third side satisfies it. So you would either say yes or no if it satisfies that. All right, excellent. So that was page 8. All right, let's move on. So you guys are in charge of these and these. All right, excellent. Keep going. Okay, next we're going to give page 10 a try. Page 10, huh? So we did page 8. And then, let's see, 10, 11. Oh, wait, actually, we're going to do page 11. So we're jumping to page 11. All right, so let's jump to page 11 here. All right, so we're jumping to page 11. All right, so, okay. So moving on to page 11, use the proof to see if this works, right? So this is a parallelogram, right? So using the parallelogram rules, knowing the parallelogram rules, we need to prove that these two triangles are congruent. All right, so just fake it till you make it, right? Parallelogram, so it's parallelogram, it was a given. All right, angle K equals M. I have no idea what's going on, I'm just faking it. So I know that this angle is equal to that angle. All right, I can kind of mark it, but I'm not sure how. So without like running over this X. So I'm just going to circle them from right now. We also know that KL is parallel to JM. So these are parallel. So let's see. KL. So this is parallel to this. Now, how would you mark that? You would actually put arrows on here. And that means that they're parallel. Same thing with the K. I'm just going to circle them but it's really like this is equal to that. All right, just helping you guys out there. Okay, and now we're saying, now why would these angles be congruent? So it has to do with what we just said here, right? So if the lines are parallel, why would these angles be equal? All right, so we're talking about angle L and angle J. So KLJ, so we're talking about this angle. So I'll put a double here because we already have single rocking, is equal to angle J. They said LJM, so this angle right here. Now, why were those angles equal? So let's see. Are they consecutive interior, alternate interior corresponding, or alternate exterior? Well, actually, those right there are just alternate interior because that's our best friend is a z, right? Okay. All right, so that was that proof. All right, moving on. Okay, number 2. Which method listed below cannot be used to prove the triangles are congruent? Okay, and if you can't remember, like, what are the rules here? Look, here, so proving triangles are congruent are right here. So you would label as you go, you do your givens. Remember, if there's parallel lines, your two best friends are alternate interior and alternate are alternate interior angles and corresponding angles. So those are your two best friends, right? So we're alternate interior. This is from Unit 2 stuff, where you make the z or the backwards z, and corresponding is a copy paste. So there's a big old list of stuff that you can do. All right. Which method listed below cannot be used to prove the two triangles are congruent? All right, so how do we prove the triangles are congruent? So basically, here's all the combinations. We have, excuse my language, but you have ass and ass backwards, and because you always remember the naughty stuff, and your triple A. So people in my class know what that means. You can just, you guys can just complete the sentence. All the other combinations are good. And the only time you can have ASS, ass, is if you have a leg, hypotenuse leg. So if it's a right triangle and you had ass, it's all right. So that's the only catch. All right, sweet. Okay, so which method? So prove all sets of sides are corresponding. So that would be SSS, right? Okay, so that works. Prove all sets of corresponding angles. That's AAA. So that's no good, right? Okay. Prove that two sides and an included angle. So you have two sides and an angle in the middle. So that's two sides and an angle in the middle, and that's still good. And then two angles with one of the sides in the middle. So sides in the middle. Boom. So those are good. So which one was not good? So that would be B. So we had 3 check marks and 1 X. All right. Parallelogram. So we have this. Which pair of triangles can be established congruent if we prove that these two angles are equal? All right, so let's see. So if I said the angle A, so DAE, so this angle right here is equal to BCE. So BCE, so this B angle right here. Okay, so what do we know? All right, so if I focus on everything, so DAE, where's DAE? So this triangle right here. So in this one, we have this little triangle right here, and CBE, this triangle right here. All right. So first of all, DAE. So we know, so DAE, right? And C. So does D equal E? Sorry, does D equal C? So first of all, that doesn't feel right off the bat, right? Does it? So this letter is supposed to match up with that letter. That's like stuff like that. So these particular letters are supposed to match up with each other. So we're supposed to have A is equal to C. So A has to equal C no matter what. That's our first goal. So A has to match up with C. So this one's already out. So that just does not work, right? So that doesn't work. Okay. And then, so we just keep trying stuff, right? So how about this? Does E equal E? Yeah. So these two angles right here are equal to each other, right? So E equals E. So basically, I'm just going to keep separating stuff until this works out. So does EAD? So if I go EAD, does that equal ECB? Yeah, that actually does look like it works. All right, and then we try another combination. All right, so if we do A, B, E. Okay, already this feels wrong because that triangle, that angle that they gave to us is not even a part of this triangle that we're making. So that's not going to work at all. Okay, and how about and I'm not even going to bother with the other part. Okay, and how about BAE? So BAE see, that's not even part of the triangle that we're talking about. So like this angle has to be part of the triangle. So the only one that worked was B. All right. So all right, number 4. All right. So number 4 in the figure, AB, and I have no idea what's going on. I'm just gonna mark stuff. AB. So here's AB is equal to DE. Boom. And that's how I mark that they're. So I did a single notch to mark them that they're congruent. Angle B, and make a curve, is equal to angle E. Make a curve. Choose the correct congruency statement that we get. Okay, so looking at this, so which one proves that things are congruent? Right off the bat, one of these is going to be bad. Which one is bad? Right there, ass backwards. That's definitely not going to be one of them. So D is definitely out no matter what. Okay, so if I, just to help you focus on what I'm talking about, I'm just going to redraw these triangles these 3 times because we don't care about this other one. All right, so right off the bat, we have this. These are all equal, and this angle is equal, right? All right, so let's do the extra one. Angle A, so I'll put a double here, is equal to angle D. All right, so what do you have more of, angles or sides? Angles. So go to the third angle that you don't have and go into a circle, and we get angle 1, sorry, we get angle 2, side 1, angle 1. And we get the same thing on this one, right? Okay, so it's ASA, so that works. All right, so boom. Okay, how about this one, CB? So C to B was this, so I'll put a double because single's already being used, and FE. And I'm going to put double. Okay, so what do you have more of, angles or sides? Sides, so you go to the third side you don't have. Go in a circle, we get side 1, angle 1, side 2. So I'll put that over here, side 1, angle 1, side 2. And if I go in the circle, this one get the exact same thing. So side, angle, side. Yep, that works. And this one, C is equal to F. So I'll put a double here. And let's see, I have 2 angles. So go to the third angle you don't have, and now go in a circle. Doesn't matter which way you go. So if I go in this direction, side 1, angle 1, side 2. So side 1, angle 1, angle 2. And I would do the same thing here. That works. Wait a minute, I said AAS. Oh, I just have this backwards. So angle 2, angle 1, side 1. Now, does it work? Yeah. So all those worked, and the one that didn't work was this. And they said choose the correct congruency statement, select all that apply. So A, B, and C were the ones that worked. So all 3 of those worked except for D. All right, and down here. So given AC is perpendicular. That's what that means, perpendicular. So perpendicular to BD, so that means that they meet at a 90-degree angle. So 90-degree angle here and here, right? And A is equal to C, that's already marked. Which method would prove that these triangles are congruent? All right, now I see that this is a right angle. And I know you guys want to go hypotenuse leg, right? But that's not always true. Hypotenuse leg is a fallback. It's a fallback. If we end up getting ASS, you would fall back to see if HL works. In this case, we have angle, right? So the other thing that we would try, so we did all of our givens, then you would do the reflexive property, right? Reflexive property where they share a side. So this side right here. Now, what do you have more of, angles or sides? We have more angles. So go to the third angle you don't have, go in a circle, and we get angle 1, angle 90, and side 1. Now do it on the other one, do you get the same combination? Yeah, we get angle 1, angle 90, and side 1. All right, so is AAS good or bad? That is good because we didn't cuss, right? We didn't cuss, so that works. And now let's make sure that the combinations work. Does A, B, D? So I went this angle 1, nothing, and then angle 90. Do you do the same combination here? C, B, D, yes. So are these congruent? Yes or no? Yes, AAS, or you could say SAA. Both of them mean the same thing. Awesome. All right, so that was page 11. All right, and now we're going to page 12. All right. So here is page 12. All right, so page 12. All right, so we are just going to mark stuff and just see what happens, right? So first thing you always want to do are your givens. So we have this one, and then this one is special because it's going to feed into the next thing. So so it says bisect, so the thing right after that needs to say bisect. So there's the word bisect. So these two need to go together. All right. So I'm going to do AB and CB are equal. All right. And then you would just write down whatever that goes to. And then we have BD bisects angle ABC. And you make sure you're marking your stuff as you go. So AB is equal to BC, CB. And then we know that these two bisect. So BD bisected what? It bisected an angle. So that means that two angles are going to be equal to each other, right? So what got cut in half? B. B got cut in half. So that means that this side will be equal to this side. So that feeds into basically angle B is equal to angle B on the left and the right side. So which one is talking about angles? So it's either this one or this one, right? Okay, so both of them are, so this one's saying angle A is equal to C, so not that one, this one. B is equal to B, that's the one we want, so we want H. So A, B, D is equal to C, B, D. So there we go, so that was the H one. All right, okay, and then reflexive property. So where's the reflexive property on here? That's where they share sides, so that'd be this one. I'm gonna put a double on it because singles are already being used. So basically BD is equal to BD, so we're talking about sides. So BD is equal to BD, that would be the better choice, so that'd be C. BD is equal to BD. Okay, and then finally, you're always the last thing you want to, your last statement is always what you're trying to prove. So that's triangle ABD is equal to triangle CBD. So it's going to be triangles equal to triangle. So and look at this. So you see these two right here, tricky little buggers. They put they have angles right there. So B is the better answer. So a lot of people will see the D and like, oh, it's that one. No, it's this one. So it's supposed to be B right there. Awesome. Okay, and then so this is a lot about faking it until you make it. All right. So make sure you have the letters down. Mark off as you go. All right. So here we go. So number 2. Okay, remember, always the last thing you're trying to prove is your last statement. So that's already set. So now they're just doing the reasons behind everything. So just fake it. Why is angle R equal to angle T? How did we know that? Okay, that was given to us. All right, and then, so we did that one. Okay, why is QR, so QR, mark it, is equal to UT. Now, how did we know that? And notice I'm marking my picture. It's very important that you do it. How did we know it was given? Okay, next they said angle S is equal to angle S. So I'm going to put a double because singles are being used. Why were these two angles equal? Because they're vertical to each other. Now, why would these two triangles be congruent? So what do you have more of? Angles or sides? Angles. So start here, go in a circle, and we get side angle angle. Side angle angle, or you guys could say angle angle side. So in this case, they said angle angle side. And now, and if you look at your Hot Topics page, why would these two things be equal? Well, if you have to go a step further than triangle congruency, right here, it would be CPCTC, corresponding parts of congruent triangles congruent. So once the triangles are congruent, all of its parts, congruent parts, are congruent. So CPCTC. So corresponding parts congruent triangles are congruent. Excellent. Okay, and number 3. Okay, so just mark stuff. So why are these two parallel? Because it was given. Okay, now once you say lines are parallel, your two best friends are alternate interior and corresponding. So alternate interior is you do the Z, corresponding is just a copy paste. So look at this. Why would angle Q, so they said RQS is equal to TSQ. So do you think that's copy paste or you think that's Z? That's Z, so that's the alternate interior. And then why would R be equal to T? So why are these two angles? R is equal to T. And the reason was that is because it was given. So look at this. As soon as we said lines were parallel, right here, that's special because as soon as we say lines are parallel, that feeds into alternate interior corresponding. So as soon as we said lines are parallel, we had to feed off of that. Now we can finish off and do the other given. All right, and so we can keep marking as you go, right? And then they said QS is equal to SQ, so I'm going to put a single right there. Now, why is this side on this triangle equal to that side on the other triangle? It's the same triangle, so that would be reflexive. Okay, and then why are the two triangles congruent? Okay, what do you have more of, angles or sides? We have angles, so we're going to go in a circle and we get angle, angle, side, or side angle, angle. Both are the same thing. And then if we had to feed off more of it, why would these two sides be equal? Once you prove that triangles are congruent, which is what we did here, once you prove the triangles are equal, if you have to take a step further, it's usually CPCTC. So CPCTC, corresponding parts congruent triangles are congruent, and which is right here. It's never prove. Prove is never going to be one of the things you say. All right, and number 4. Okay, so this is these two are proportional to those. Okay, so it was given. So we're saying that these two triangles are proportional to each other. We have no idea what's going on, but we're just going through stuff, right? So, FE and FD are proportional to each other. So this and this are proportional, and this are proportional. We know that angle F is equal to angle F. So boom. Okay, because reflector property, right? We know the two triangles are similar because of SAS similarity. So then they blank corresponding angles are congruent. Okay, have no idea what's going on, but let's see. Angle E and G. Does E and G go onto the two congruent triangles? We're talking about the little triangle, we're talking about the big triangle, right? So this is FEG and FDH. So does E and G, do they correspond on either triangle? That doesn't work. Does F and F? Does F and no, those are the same triangle. So that is the same angle. Does E match up with D? E and D match up. Yeah, that should work. And does D and H? D and H. No, that's on the same triangle. They don't correspond on either thing, right? So the only thing that works is C, where for this angle right here corresponds with that angle right there. And now we can do a copy paste job of corresponding angles, right? So we have, so with C, which is just that. Boom. Okay, and now that we have, why would these two be congruent? Because of reasons. Okay, all right, so that's the 30-minute mark. There were some other pages that we could work on. Let's see. Triangle Inequalities, so page 9. So let's backtrack. Let's go a little further and see if we can do these other pages real quick. So running a little farther than I wanted, but it'd be nice just to get these done. All right, so triangle inequalities. So we know that find x and y. Okay, you see how these two sides are equal? All right, so that is this. So if your arms are equal, then your elbows are equal, right? And vice versa. If your elbows are equal, then your arms would be equal. So we would know that this angle and this angle are equal. Now, you see how that makes a straight line? That makes a rainbow straight line. So we know that 106 plus this missing angle equals 180 degrees, right? So you can find that. Once you find that, these two angles right here would be equal to each other. So, and then on top of that, we know that all these angles, all three of these angles add up to 180 degrees. So I'm sure you guys can figure that one out. All right, number 2. Okay, so you see how all three sides were equal? Well, immediately, if all three sides are equal, then we immediately know that all three of those angles are equal. And so if sides are equal, all the angles are equal. And if they're all equal, what would they have to be? They would all have to be 60 degrees. So right off the bat, all three of these are 60. On top of that, you see how these two sides are equal right here. That means this elbow and this elbow are equal. So this would have to be 72. And then all three of these have to add up to 180 degrees. So if that's 72 and that's 72, what will be left over? And then you make sure you find what they wanted. They wanted angle ABC. So they want this entire angle right here. So once you get this angle, you add those two together. All right, number 3. They said that angle L is 69. So if you just focus on the big triangle right there, and you see how these two sides are equal, if this is 69, this would be 69, right? So find this missing angle. And then, because this and this got cut in half, right? So whatever angle this is, cut it in half, and you'll find each of these individuals. And they wanted L, K, J. Actually, they wanted this whole thing. So you don't even have to cut that in half. They just want this one big angle. So that's great. All right. So over here, oh, I like this one. Okay, so this is 90, right? So if you just separate the two triangles, you'll be in a better place. So if this is 40 and these two are equal, so just turn your paper. So if this is 40 and both of these are equal, right? What would be left over? So I know that all this adds up to 180 degrees. So right now, if I take 180 and I subtract that 40, this would be 140 left over, right? So each one of these would have to be 70 degrees to complete that 140. So on top of that, if I focus on this other triangle, so this is 90 degrees, right? So if this is 90 and both of these are equal, I would have 90 left over, so this would be 45 and this would be 45. So right here, little n is 45. And I know all of this adds up to 70. So if this is 45 and the whole thing is 70, what would m have to be? So you guys can figure that out. All right, and number 5. All right, so on number 5, okay, we know that these two angles are equal. Let's see what else. We also know that these two sides are equal. Excellent. So basically, I know that this is equal to that. Well, solve it. So solve for x, and then so set those two equal, solve for x, and then make sure that you plug it back in because they wanted a to b. So a to b is right here. So once you find x, plug it back in and you'll be good to go. All right, so that was page 9. We did page 8 and 9, and then page 10, last page. Not so bad off here. All right, so this one right here, is it acute, obtuse, stuff like that, right? So all you have to do is look at this picture right here. So here's all the lists. So you can base it off of the angles, or you can base it off the sides. So if you base it off the angles, so these are the angles. If you have sides, but you still have to base it off the angles, you would use these rules. And if you're just basing off the sides, period, it would be this. All right, so not that big a deal. So if you base this off of the angles, here's a list. If you base it off the sides, here's a list. So you have to give me both on all of those. All right, so what do you notice about all the sides right here? You notice that they're all equal, right? So if all of them are equal, then let's see. I know that in all these are 60. So is it acute, rice, or obtuse? So you just base it off of those. Same thing with the sides. You guys can figure that out. Down here, you would just plot these. So here's the center right there. All right, so you would go -7. So 1, 2, 3, 4, 5, 6, 7, +1. That's my W. And then I have XY. I always write XY when I have zeros. So this is going to, the numbers with the Y, so it's going to be on the Y axis. So -4, 1, 2, 3, 4. There is my X. And +2, +3. There's my Y. And then I would take my straight edge and connect the dots. And try to be as accurate as possible. All right, so looking at that picture, and then now we're going to be looking at these sides. So the best thing you do is actually find all the distances by doing the right triangle here. All right, so this is 1, so start at the dot and go towards the corner. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 squared by 2 squared. All right, you put that in the calculator. All right, so we got 9 squared plus 2 squared. We get that right there, so that's x squared, right? So that is 85 equals x squared, so that's a square root of 85. Right, so that side's square root of 85. All right, and then right here we have, so always start at the dot and go towards the corner. So start at the dot, because if you start at the corner, you might stop a 1 early, so be careful. So we get 1, 2, 3, 4, 5, 6, 7, 7 squared, and then plus 2 squared. So 7 squared plus 2 squared, and we get basically the square root of 53, right? And then over here, we get 1, 2, 3, 4, 5, 6, 7, so 7 squared. We get 1, 2, 3, 4, 5. So plus 5 squared. So 7 squared plus 5 squared, and we get the square root of 74. Okay, so notice all the sides. Okay, all of them are different, right? So if all of them are different, then this is definitely scaling. Okay, and now looking at this is definitely, I'm pretty sure it's not a right triangle. So what's the biggest side? We have the biggest side, so this would be my C, right? How does C squared compare to A squared plus B squared? So the biggest side, how does the square root of 85 compare to the square root of 53 and 74 squared? All right, so we would get 85. How does that compare to 53? See the square root and the squares they cross out? Plus 74. So how does 85 compare to 53 plus 74? And we get 127. We would eat the bigger number. So is this less than, greater than, or equal to? That is less than, so that is an acute triangle. And you just rinse and repeat for all the others. All right, hopefully that helped you guys out. Have a great and wonderful day.